Hey guys, today we'll talk about the uniform distribution, and the topic is as straightforward as a line, well, in part because it is a line. Let's talk about the properties of the uniform distribution. So first of all of the outcomes are equally likely, and that's why the graph is a straight line. Between A and B, the probability remains the same throughout. And of course, that makes the graph a rectangle, which is pretty easy to calculate. You don't need any fancy integrals for that. You just multiply the height by the length, and you got your probability. And the total area, of course, is 1, like with all continuous distributions. Let's take a look at the formulas for the uniform distribution. First of all, f of x being some random continuous variable, equals to 1, which is the total maximum probability divided by b minus a, where x is some variable between a and b. The mean is, as you might have guessed, calculated by simply subtracting a from b and dividing that by 2, so it's the middle of the rectangle. And lastly, the standard deviation, and this one looks a bit counterintuitive, but you just have to trust me here. It equals to the square root of b minus a squared divided, for some reason, by 12. Well, there is a very good reason why that happens. However, to understand it, you may look into a mathematical proof on your own spare time. However, we are going to move on since we have problems to solve. So here's an example problem. The amount of time the customer has to wait for their delivery is uniformly distributed between 30 minutes and an hour, inclusive. Let's see what we gotta find here. The probability of waiting less than 50 minutes, how long do the customers have to wait 80% of the time, and the average waiting time and the standard deviation. Well, let's get started. First, we graph our plot for the uniform distribution here, and we have 30 minutes at the origin and 60 minutes as our cutoff point. And that leaves us with the probability of 1 over 60 minus 30, which is 0.033. Now let's try to answer the first question. And what it asks for is the area between 30 and 50 minutes. And it looks like this, and the area equals to 50 minus 30 multiplied by 0.033, which gives us 0.66, or 66%. So that means that 66% of the time, the customers have to wait somewhere between 30 and 50 minutes. The second question asks us the inverse of the first problem. We are given the probability of 80%, and we need to find what time this probability corresponds to. And to do so, we're going to reverse the formula that we just applied in our first problem, and we're going to solve for x. And 0.8 divided by 0.033 plus 30 minutes gives us 54 minutes. So that means that 80% of the time, the customers have to wait between 30 and 54 minutes. Lastly, we have to calculate the mean and the standard deviation. And this shouldn't be a problem for you since we already discussed the formulas. So the mean is going to be 60 minus 30 divided by 2, or 15 minutes plus 30, 45 minutes. So the mean is 45, and the standard deviation is 60 minus 30 squared divided by 12, and then we take the square root of that, and we get 8.66. And there you go. This is a problem solved. Thank you very much for watching. Hopefully this video was useful to you. If you have any questions remaining, leave us feedback in the comment section below, and we'll do our best to satisfy your curiosity. Thank you very much again, and take care.